Assalamualaikum everyone. I hope you're all doing great. So today we will be looking at the normal distribution from Edexcel IAL Statistics-1 chapter. Many of you face a lot of problems in this chapter. So in today's video, we will explain everything with detailed explanation to help you understand every concept clearly. So without any delay, let's start. So a normal distribution curve is very symmetrical, and the midpoint of the normal distribution curve is the mean value. This is the mean value. And there are some properties of a normal distribution curve. So all of you need to remember these properties. Some are important and some are just there to just give you an idea of how a normal distribution curve looks. The first property is that the distribution is symmetrical about the mean value, and the second property is that the mean, median, and mode are all equal due to symmetry of distribution. So if the mean value, let's say it's 40, the median and the mode will also be 40 due to the symmetry of the distribution. And the range of x, or the domain, is from -infinite to infinite. So there are infinite values of x. And the horizontal asymptote, the horizontal axis is an asymptote to the normal distribution curve. And the total area under the curve is always 1. I will explain that in a few minutes, but just remember this point. And the usual use case for a normal distribution curve is for continuous variables, for example, length of a leaf or weight of people. All right, so the normal distribution curve, let's say the area under a normal distribution curve gives you the probability of x is less than or greater than x. So it gives you a probability. So since it gives you the probability, the total probability we know is 1. So the total area under a normal distribution curve is 1. And the equation for a normal distribution curve, which has a mean value of 0, is y equals 1 over root over 2 pi e to the power negative half t squared. But you do not need to remember this formula, because this formula is not important in while doing sums of the normal distribution. Now, many of you have seen this as statistical table. So this statistical table actually represents the area under a normal distribution curve, which has mean as 0 and the standard deviation or the variance as 1. So any normal distribution curve which has mean 0 and variance 1, their areas will be equal to these values. So phi z, let me just show you all how to use this statistical table. So this is the value of z. Now you all need to remember that when doing these normal distribution sums, the values of x must always be in terms of z. It cannot be x, it cannot be y, or it cannot be anything other than z. If the values are in x form or in y form, you need to convert them to z. So let's look at the statistical table, and then we'll see in-depth explanations about the z and x stuff. Okay, so phi z, this column, actually represents the probability of z is less than z. So let's say we have phi as 1.2. If you look at the normal distribution curve, let's say that this is 1.2. If you calculate phi 1.2, you will get this area. And this area is equals to probability of z is less than 1.2. So always remember that phi z is equals to probability of z is less than z. All right. Now for this statistical table, for this equation, the mean value is set to 0 and the standard deviation or the variance is set to 1 by default. And this is where the phi z represents probability of z is less than z. This area is known as phi z. All right. Now you all can pause for a few minutes. You can just write these formulas down, or you can just take a quick screenshot. So let me just explain these formulas to you. Let's say we have probability z is greater than a. In the statistical table, we can only find out the value of z is less than a. You cannot find out the value of z is greater than a. So z is greater than a. Let's assume that this is a. If you want to find out the value of probability of z is greater than a, which means that they're talking about this region. Now, all of you know that the total probability is 1, the total area is 1. So you can say that probability of z is greater than a is equals to the total probability minus probability of z is less than a. So the total probability minus this region. So this is where the formula came in. And these are the usual formulas. You need to keep these memorized. All right. And let's say we have a range which is z is greater than a but less than b. So let's say that this is a and this is b. If you want to find out probability of z is greater than a but less than b, which means they're talking about this region, right? So they're talking about this region. So if you calculate probability of z is less than b, you'll get this whole area. And if you subtract probability of z is less than a, you'll get this area. And if you subtract it, you'll get the red regions area. So this is where the derivation of the formula comes from. And you need to remember this. I mean, you do not need to remember this formula because you can derive it using the formulas above, which is this formula. Okay. Now let's talk about the fact that if they give you the values in terms of x, in that moment you need to convert the values of x into z, and the formula to value the to convert the values are z equals x, or let's say it's if it's y, or if it's h, if it's d, anything other than z. The formula is z equals x minus the mean divided by the standard deviation. And if a variable is normally distributed, you can write it like this. It's that x is normally distributed across the mean and the variance. Or you can just write it as standard deviation squared. Now let's look at an example. Let's say that x is normally distributed across the mean and standard deviation squared, or variance. So always remember that a normal distribution format is in this form, which is the first coordinate will be mean and the second coordinate will be variance. variance or standard deviation squared. Right. Now, if they tell you to find out the probability of x is greater than 5, first of all, you need to convert this value of 5 to z. So you can replace x with z and 5 with x minus mu over the standard deviation. In this case, the value of x is 5 and the value of mean is 3 and the value of standard deviation is 5. So now you have this expression. Now you need to calculate the value of, you cannot calculate the value of z is greater than 0.4. You need to convert this into less than sign. So you can write it as 1 minus probability of z is less than 0.4. And when the value of z is 0.4, the probability would be, you need to go back to the statistical table. When the value of z is 0.4, 0.4 is at this point, the value of probability is 0.6554. So there's your 0.6554. So the final answer is 0.3446. Now let's look at another question. Is that x is normally distributed across the mean as 4 and the variance as 49 or 7 square. Now, first of all, they'll tell you to find out the probability of x is greater than 3 but less than 10. So you can write it in this form, which is probability of x is less than 10 minus the probability of x is less than 3. And then you need to convert these values to z. So you can use the formula that z equals x minus the mean divided by the standard deviation. So the standard deviation is 7 and the value of mean is 4. So this is equals to around 0.86. And this will give you a value of negative 0.14. And if you use the formula we have seen above, which is this one, if you have a negative constant, you can write it as 1 minus probability of z is less than a. So we can, since there's a minus sign at the front, we can replace this with minus 1 plus probability of z is less than 0.14. And when the value of z is 0.86, the value of phi z is 0.8051. And the value of this is 0.5557. We calculated these values from the statistical table, these two values. So the final answer is 0.3608. Now let's look at another sum, a much complicated sum. It's not complicated, it's just one of the values is negative and the other value is positive, and both of them are given in fraction. All right. So as usual, you can write it like this. You can write it like this. Let me just recall this, because the normal distribution curve looks like this. This is negative 1 over 7 and this is 6 over 7. So the total area, which is probability of x is less than 6 over 7, the total area is this, minus probability of x is less than minus 1 over 7, which is this area. Then you will get the required area, which is the red region. All right, let's erase this. Okay, and then you need to convert the values of x to z. So the value of x is 6 over 7. So the formula was z equals x minus mean divided by the standard deviation. In this case, the standard deviation is 7 and the mean is 4. So it gives you a value of z is less than negative 0.45, and this gives you a value of negative 0.59. So if you want to make this these values as positive, you can use the formula I have shown in the previous part. So the final answer is 0.0488. Now let's look at another topic. It's that in the previous sums, we have seen that they gave us a value of z and we need to find out the probability, right? But in this part, they will give you the probability and then you will need to find out the value of z or x, or the most common part, you need to find out the value of mean and standard deviation. So let's see how we can do this. Let's say we have a distribution is that x is normally distributed across, the mean is unknown and the variance is 9. So the standard deviation will be 3. And they will give you an information, it's that the probability of x is greater than 20 is 0.2. Okay, so I have written out a process, is that the first step, you need to convert the values of x to z. So we have done it in this part using this formula, so that z equals x minus mean over the standard deviation. And the second step is that we need to identify the sign. If it's a greater than sign, we need to subtract the probability from 1. Or if it's a less than sign, we can just keep it as it is. In this case, it's a greater than sign. So we need to subtract this probability from 1. So that's what we have done in this part, and then we can change the sign. So now the probability of z is less than 20 minus mu over 3 is 0.8. Now if we look at the statistical table, when the probability is 0.8, this is the probability, right? So when the probability is 0.8, we can find out the value of z. But as you can see that in the statistical table, the closest value of phi z to 0.8 is this one, which is 0.7995. So we can just choose this value. We do not have an exact value for 0.8. So when the value of phi z is 0.7995, the value of z is 0.84. So now we can say that this value is equals to 0.84. Now we can just solve the equation as usual and get the value for mu. Alright, now let's look at another case, is that x is normally distributed across the mean, which is mu, unknown, and the variance, which is 40. So the standard deviation will be root over 40. And they have given us an information, is that the probability of x is less than 25 is 0.15. Now the steps I have wrote in this part, you all can just pause and just screenshot this, because these are very important steps in order to find out the value for mu or standard deviation. The first step, convert the values of x to z. So we have done it in this part using this formula. It says z equals x minus mean over the standard deviation. All right. Now the second thing is that we need to identify the sign. If it's a less than sign, you can just keep it as it is. So in this part, it's a less than sign, so we can just keep it as it is. Then we need, the final step is that we need to check the constant value, that is the probability in this part. This is the constant value. If the constant value is greater than 0.5, you can keep it as it is. But if it's less than 0.5, there is a problem. So let me tell you about the problem. It's that the probability, if the probability is less than 0.5, for example, in this case, it's 0.15, which is less than 0.5. Now, if you look at this statistical table, you can see that the value of phi z, which is in case the probability is, the value of probability does not uh, exist below 0.5. So if your probability is less than 0.5, that's a huge problem for you. So let me show you how to do that, how to overcome that problem. So the first thing, keep in mind these steps. So the first thing that you need to do is that subtract 1 from it. So subtracting 1 from it will give you negative 0.85. And then what you need to do is that since there are no negative values of probability, you need to take this negative sign to the left hand side of the equation. So now it's a positive value. Now when the probability is less than, when the probability is 0.85, we need to find out the value of z. So looking at the statistical table, there isn't an exact value for the probability to be 0.85, but we have a close enough value which is close to 0.85, which is 0.8508. You need to take the closest value as possible. So for this, the value of z is 1.04. So now you can finally say that this value is equals to 1.04. But there is a twist, is that since there's a negative sign at the front, you need to keep a negative sign at front of the value of z. So now you can just solve the equation as usual. So I hope you guys all enjoyed the video so far. Before we dive into solving normal distribution questions, here's a quick announcement. If you're appearing for any maths units in AS or A2, whether in 2025 sessions or 2026 sessions, you can join our two signature courses. The number one is the Impact Crash Course, and the number two is the Question Papers Marathon Course. For complete details, check the description below. To enroll, text us on WhatsApp or reach out via our Facebook page, Exam Essentials. Now let's ace our Edexcel and Cambridge O-Level or A-Level exams together. Now we will be solving a couple of questions from the textbook in order to clear all of your problems regarding this normal distribution chapter. So starting off with the first question, this is from exercise 7E, number 12. So loom makes tablecloths with an average thickness of 2.5 millimeters. So the mean value is given as 2.5 millimeters. So the mean is 2.5. All right. Now the thickness T millimeters can be modeled using a normal distribution. So we can say that T is normally distributed across the mean. The mean value is 2.5. And variance. We don't know the value of variance. They did not give us the value of variance. They have just said that given that 65% of tablecloths are less than 2.5 millimeters thick. So let's say that the variance is standard deviation squared, which is unknown. All right, now for the first part, we need to find out the standard deviation of the thickness. Now we have an information to work with. It's that given that 65% of the tablecloths are less than 2.5 millimeters thick, which means that the probability of tablecloths which are 2.5 millimeters thick is 65% or 0.65. So that is the percentage is basically your probability. So we can say that the probability for T to be less than 2.55 is 65% or 0.65. Now what you need to do is go back to the statistical table, and we know that the probability is 0.65. But first of all, we need to convert this value of t into z. So we can replace t with z, and 2.55 with 2.55 minus the mean value divided by the standard deviation equals 0.65. Now we know that the probability is 0.65. So if we go back to the statistical table, so in this statistical table, when the value of phi z, which is the probability, is 0.65, we need to find the value of z. So we do not have an exact value for 0.65, but we do have a close value, which is very close to 0.65. That is 0.6517. This is very much close to 0.65. So we can take this value, and when the value of phi z is 0.6517, the value of z is 0.39. Now we can say that this is equals to 0.39. So we can say that 2.55 minus 2.5 should give us a value of 0.05. So 0.05 over the standard deviation is equals to 0.65. So the standard deviation is equals to 0.13. So that is it for this part. Now moving on to the second part. We need to find the proportion of tablecloths with thickness between 2.4 millimeters and 2.6 millimeters. So basically, we need to find the probability for the thickness to be greater than 2.4 millimeters but less than 2.6 millimeters. Now, if we use a normal distribution curve, let's say that this is 2.4 and this is 2.6. We need to find out this area. So in order for that, if we calculate the probability for t less than 2.6, we will get this area, this whole area. And if we calculate probability for t less than 2.4, we will get this area. And if we subtract this area from the whole area, we will get our required area. So this is subtracted. Now we need to convert the values of t into z. So probability t less than 2.6 minus the mean value divided by the standard deviation. The standard deviation was 0.13. And same goes for this part. So this gives us a value of, it's not t, it's z. So this gives us a value of z is less than 0.77. And this gives us a value of negative 0.77. And since this is a negative value, we can use this formula. It's that the probability of z is less than negative a is equals to 1 minus probability of z is less than a. So this is a formula. You all need to memorize this. This will not be given in the formula booklet. So since there's a minus sign at the front, we can replace this with minus 1 plus the probability of z is less than 0.77. Now there are two identical values. So we can write this as 2 times the probability of z is less than 0.77 minus 1. Now, in order to get this value, you need to go back to the statistical table and find out the value of phi z. So the value of z was 0.77. So when the value of z is 0.77, the value of phi z is 0.7794. So now we can replace this with 2 times 0.7794 minus 1. So this is equals to around 0.5591. Oh, it's not 91, it's 0.5588. So that is it for the first question. Now moving on to the next question. This is from exercise 7E, number 11. So let's start. An automated wheel is used to make bolts. The diameter of the bolt's diameter is normally distributed with mean mu and standard deviation 5 millimeters. So we can say that D is normally distributed across the mean and standard deviation squared. Given that 75% of bolts are greater than 200 millimeters in diameter, so bolts which are greater than 200 millimeters in diameter, the probability of those bolts are 75% or 0.75. You always need to remember that the percentage is your probability. So now we need to calculate the value of mu. So we know that the probability for the diameter to be greater than 200 millimeter is equals to 75% or 0.75. So now since this is a greater than sign, we need to convert this to a less than sign using this formula. I'll write down the formula. Probability of z is greater than a can also be written as 1 minus probability of z is less than a. I have talked about how this formula came in my previous part when I was explaining the normal distribution chapter. So if you're still confused about this formula, I mean how it came, how it was derived, you can go back to the part where I explained this. So this can be written as 1 minus probability of t less than 200 equals 0.75. So overall, this gives us a value of 0.25. And now we need to convert this value of t into z. So we can replace this with z is less than 200 minus the mean value divided by the standard deviation. The standard deviation is 5. Now what we need to do is that check the constant value. I've explained this in my previous part, but I'll give a recap, is that if the constant value is greater than 0.5, you can keep it as it is and continue with your sum. But if it is less than 5, what you need to do is that subtract 1 from it. If you subtract 1, you will get negative 0.75. Now since there are no negative values for probability, you can take this negative sign and move it to the left hand side of the equation. So it can be written as minus b. Now we know that the probability is equals to 0.75. So when the value of phi z is 0.75, we need to find out the value of z. So we need to go back to the statistical table. So when the value of phi z is 0.75, now we do not have an exact value for 0.75, but we have a value which is very close to 0.75, which is this one. So we can say that the value of z is 0.67. So we can say that this value is equals to 0.67. So 200 minus the mu divided by 5 equals 0.67. Now there's a negative sign at the front, So you need to include the negative sign in front of the value of z. So by solving this equation, we can get the value for mu. So the value of mu is around 203 millimeters. So that is the answer for the first part. Now moving on to the second part, we need to find out the value for probability to be less than 206 but greater than 204. So we calculate the probability for t to be greater than 204 but less than 206. So if you look at the normal distribution curve, let's say that this is 204 and this is 206. Basically, we need this area. We need this area. Now, if we calculate this value, which is the probability for d to be less than 206, you will get this area, this whole area. And if you calculate probability for d to be less than 204, you will get this area. If you subtract this area from the whole area, we will get our required area. So we just need to subtract it. So now let's calculate these values. Now we need to convert these values of d into z. So we can say that probability of z is less than 206 minus the mean value. The mean is 203 divided by the standard deviation minus, same goes for the second part, z is less than 204 minus 203 divided by the standard deviation. So this gives us a value of 0.6. And this gives us a value of 0.2. Now if we go back to the statistical table, when the value of z is 0.6, the probability is 0.725. So we can replace the first part with 0.7257. And when the probability, when the value of z is 0.2, the probability is 0.5793. So we can replace the second part with 0.5793. So overall, this gives us a value of 0.15. So that is it for this part. Now moving on to the second part, 3 balls are chosen at random. Find the probability that all 3 balls are greater than 205 millimeters in diameter. So let's first find out the probability of a ball to be greater than 205 millimeters in diameter for one single ball. So for part C, let's first find out the probability of d to be greater than 205. So we can write this as 1 minus probability d less than 205. We have talked about this formula in the previous part. We can look those up. Then we need to convert this value of d into z. So it's probability d less than 205 minus the mean value divided by the standard deviation. So this gives us a value of 0.4. Now if we go back to the statistical table and find out the value for probability when the value of z is 0.4. So when the value of z is 0.4, the probability is 0.655. So we can replace this with 1 minus 0.6554. So this is equals to around 0.3446. Alright, so this is the probability for the diameter to be greater than 205 millimeter. This is just for one ball, but we're talking about 3 balls in this part. So the first bowl will be greater than 205 millimeters, and the second bowl, since this is an independent event, this is a dependent event, the probabilities will be multiplied. The second bowl will be same, greater than 205, and the third bowl will be greater than 205. So basically you can write this as probability D greater than 205 whole cubed. So we can replace this with 0.3446 whole cubed. So the answer will be 0.04. So that is it for this part. Now moving on to the next question. This is from chapter review 7, number 5. So a machine puts liquid into plastic cups in such a way that the given volume of liquid is normally distributed with a mean of 120 milliliters. So we can say that, let's call the volume V. So we can say that V is normally distributed across the mean and variance. So I think we do not know the variance. Okay, the cups have a capacity of 140 milliliters, and the probability that the machine puts in too much liquid so that the cup overflows is 0.01. Okay, so we do not know the standard deviation nor the variance, so we can write this as a standard deviation squared. But we know information that the cups have a capacity of 140 milliliters, and the probability that the machine puts in too much liquid so that the cup overflows is 0.01. Now, in the first part, we need to find out the standard deviation. So the probability for the volume to be greater than 140 milliliters is equals to 0.01. Since they're talking about overflowing of the cup, overflowing will occur if the volume is greater than the capacity of the cup, which is 140 milliliters. So now let's solve this. First of all, this is a greater than sign, so we need to convert this to a less than sign. So we can replace this with 1 minus probability of V less than 140 is equals to 0.01. We have talked about this formula in the previous part. If you still have confusion, you can go back to the previous lessons and catch up with it. So the probability for V to be less than 140 is 0.99. Now we need to convert this value of V into Z. So we can convert this into Z using Z equals V minus the mean divided by the standard deviation. So Z is less than 140 minus the mean value, which is 120, divided by the standard deviation, equals 0.99. Now we know that the probability is 0.99. Now we just need to find out the value of Z from the statistical table. So now we need to go back to the statistical table. So from the statistical table, when the value of phi Z is 0.99, we can find out the value of Z. So we do not have an exact value for 0.99, but we do have a very close value, which is 0.9898. And when the probability is 0.9898, the value of Z is 2.32. So we can say that this is equals to 2.32. And 140 minus 120 is 20. So 20 over the standard deviation is equals to 2.32. So from this we can find out the value of standard deviation, which is equals to around 8.62. So that is it for the first part. Now in the second part, we need to find the probability that the machine puts in less than 110 milliliters. So basically we need to find the probability for volume to be less than 110. First of all, we need to convert this value into Z. So the probability of Z is less than 110 minus the mean divided by the standard deviation, which is 8.62. So this gives us a value of negative 1.16. And we can use, since there's a negative value, there are no negative values of z, we can convert this using this formula, which is probability of z is less than negative a. This can be written as 1 minus probability of z is less than a. If you're still unsure about this formula, you can go back to the previous lessons and clear this up. And the second thing is that this formula will not be given in your formula booklet, so you all need to memorize this. So this can be written as 1 minus probability z is less than 1.16. Now we need to go back to the statistical table and find out the value for probability when the value of z is 1.16. So when the value of z is 1.16, the probability is 0.877. So we can replace this with 0.877, which is equals to 0.123. So that is it for this part. Now moving on to the next part. 10% of customers complain that the machine has not given enough liquid. Find the largest volume of liquid to the nearest milliliter that will lead to a complaint. So 10% of customers explain that the machine has not given enough liquid. So we need to find out the largest volume of liquid that will lead to a complaint. So let's assume that the largest volume of liquid is, let's say it's X. If the machine gives us liquid which is less than X, gives us a volume of liquid which is less than X, it will lead to a complaint. So we can say that the probability for the volume to be less than X is equals to 10%, because 10% of the customers is complaining. So your percentage is your probability. So it's 0.1. Now we need to convert this value of V into Z. So we can write this as probability of Z is less than X minus the mean value, which is 120, divided by the standard deviation, which is 8.62. So this is equals to 0.1. Now the inequality sign is less than, so we can keep it as it is, but the constant value, which is the probability, is less than 0.5, so we need to subtract 1 from this. If you're still unsure about this method, you can go back to the previous lessons and watch those to clear up your confusion. So this is equals to negative 0.9, and the value for probability cannot be negative, so we can move this negative sign to the left hand side of the equation. So this will be minus probability z is less than something equals 0.9. Now we know that the probability is 0.9. Now we need to go back to the statistical table and find out the value of z. So we do not have, unfortunately, we do not have an exact value for 0.9, but we do have a close value, which is 0.8997. So we can take this, and the value of z is 1.28. So we can say that this is equals to 1.28. So x minus 120 divided by 8.62 equals 0.9. Now there's a negative sign at the front, so we need to bring this negative sign in front of the value of z. So if we solve this equation, we will get our required value, which is x. So the value is 112 milliliters. So that is the answer for this part. Now moving on to the next question. This is from chapter review 7, number 6. So let's just start. The random variable x is normally distributed across the mean and variance. So the mean and variance or the standard deviation is unknown. The lower quartile of x is 20. and the upper quartile is 40. We know that the lower quartile is basically the 25th percentile, and the upper quartile is 75th percentile. So if we look at the normal distribution curve, let's say that the lower quartile is, so the lower quartile is 20. So let's assume that in the normal distribution curve, this is 20. So the percentage of this, or the probability, which is the area under the graph, will be 0.25, which is 25%. So we can create an equation is that the probability for x to be less than 20 is equals to 0.25. And the first thing we need to do is that convert this value of x into z. So we can say that z is less than 20 minus mean over the standard deviation is equals to 0.25. Now as you can see that this constant value is less than 0.5, which is a problem. So the step was to subtract 1 from it. So we will get negative 0.75. Now as you can see that the probability cannot be negative, so we can move this negative sign to the left hand side of the equation. Alright, so now we know that the probability is 0.75. Now we need to go back to the statistical table. So in the statistical table, there is no exact value for the probability to be 0.75, but there is a close value, which is this one. So when the probability is 0.7486, the value of z is 0.67. So we can take this value. So we can say that this is equals to 0.67. So 20 minus mean over the standard deviation is equals to 0.67. Now since there's a negative sign at the front, there will be a negative sign in front of the value of z. So we have an equation which is mu minus 20 is equals to 0, or we can just write it like this. It's that mu minus 0.67 standard deviation is equals to 20. So this is our first equation. Now in order to get the second equation, we need to use the upper quartile. The upper quartile is 40. Let's assume in the normal distribution curve that this is 40 and the upper quartile is basically the 75th percentile. So this area is basically 75%, which is 0.75. So we can say that the probability for x to be less than 40 is 0.75. Now we need to convert this value of x into z. So we can replace x with z and 40 with 40 minus the mean value divided by the standard deviation. And we know that when the probability is 0.75, the value of z is 0.67. So we can say that this is equals to 0.67. So 40 minus the mean value divided by the standard deviation is equals to 0.67. So we have another equation which is mu plus 0.67 times standard deviation is equals to 40. So this is our second equation. Now if we solve these two equations simultaneously, we will get our values of mu and standard deviation. So the value of mu, or the value of mean, is 30 and the value for standard deviation is 14.9. So that is the answer for this part. Now moving on to the next part, we need to find the 10% to 90% interpercentile range. All right. So basically, let's assume that let's first work with the 10% percentile range. Let's assume that this is A. We do not know the value of A, but we know that wait, we know that this is the 10th percentile range. So the probability for this will be 10% or 0.1. So from this, we can get the value for A. So we can say that the probability for x to be less than A is equals to 0.1. Now let's convert this value of x into z. So probability for z to be less than A minus the mean value divided by the standard deviation is equals to 0.1. Now as you can see that the constant value is less than 0.5, which is a problem, so we need to subtract 1 from it. So subtracting 1 from it will give us negative 0.9. Now since there are no negative values for the probability, we need to move this negative sign to the left hand side of the equation. So this will be negative probability something is equals to 0.9. So when the probability is 0.9, we need to get the value for z. So we have a value which is close to 0.9, which is this one. The value of z is 1.28. So we can say that this is equals to 1.28. So A minus 30 divided by 14.9 is equals to 1.28. Now since there's a negative sign at the front, there will be a negative sign in front of the value for z. So from this equation, we will get our value for A. So the value of A is 10.9. So this is 10.9. This is the 10th percentile range. I mean the 10th percentile. So this is 10th percentile. All right. Now let's move on to the 90th percentile range. So let's assume that the 90th percentile lies in this part. Let's say that this is the 90th percentile. We do not know the value for the 90th percentile. Let's assume that this is B. But we know that this area is 90%. And our percentage is our probability. So this is 0.9. The probability of this is 0.9. So from this we can create an equation. It's that the probability for x to be less than b is equals to 0.9. Now let's convert this value of x into z. So it's z is less than b minus the mean divided by standard deviation is equals to 0.9. Now we know that when the probability is 0.9, the value of z is 1.28. So we can say that this is equals to 1.28. So b minus 30 divided by 14.9 is equals to 1.28. So from this we will get our value for b. So the value of b is around 49.1. Now basically we need to find the 10% to 90% interpercentile range. So let's assume that this is 10% and this is 90% and this is 100% and this is 0%. Basically we need this length. So we know that at 90% the value is b. The value is b, which is 49.1. And at 10% the value is 10.9. And we need to subtract these two values because 10% represents this length and 90% represents this length. We actually need this length. So this is equals to around, so this is equals to about 38. So that is the answer for this part. Now let's move on to the next question. This is a question from chapter review 7. Number 7, the heights of seedlings are normally distributed. So the height is normally distributed across the, so we do not know the mean and the variance nor the standard deviation. Now, given that 10% of the seedlings are taller than 15 centimeters and 5% are shorter than 4 centimeters, find the mean and standard deviation. So the mean and standard deviation is unknown. Now, given that 10% of the seedlings are taller than 15 centimeters, so probability for the height to be greater than 15 is 10%. Your percentage is your probability, so it's 0.1. Now we need to convert this greater than sign into less than sign. So we can do that simply by using this formula. So if you make the probability the subject, you'll get 0.9. Now, if we go into the statistical table, you'll find that when the probability is 0.9, the value of z is 1.28. First of all, we need to convert this value of h into z. So the probability for z is less than 15 minus mean over the standard deviation is 0.9. So we can say that when the probability is 0.9, the value of z is 1.28. So it's 1.28. So 15 minus mean over the standard deviation is 1.28. So from this we can have an equation which looks something like this. So this is our first equation. Now, in order to get the second equation, we need to use this information, is that the 5% of the seedlings are shorter than 4 centimeters. So we know that the probability for h to be less than 4 centimeters is 5%. Basically, your percentage is your probability. So it's 0.05. Now, first of all, we need to convert this value of h into z. So its probability of z is less than 4 minus mean over the standard deviation is 0.05. Now, as you can see that the constant value, which is the probability, is less than 0.5. So that's a big problem. So in order to overcome this problem, you need to subtract 1 from it. So you'll get negative 0.95. Since there are no negative values of probability, we can move this negative sign to the left hand side of the equation. So that's move that. Now we know that the probability is 0.95. Now if we go back to the statistical table, the first, the closest value we can get are these two values. Now the question arises is that which one should you take? Because both of them are close to 0.95. The difference is the same. So the question is, which one should you take? You always remember that you need to always take the first value, which is close to 0.95. So this is the first one, which is close to 0.95. So the value of z is 1.64. So if the difference isn't much, let's say that for both of these values, the difference from the original value is 0.005. The difference are equal. So take the first value, which is close to 0.95, that is z equals 1.64. So we can say that this is equals to 1.64. So 4 minus mean over the standard deviation is equals to 1.64. Now, since there's a negative sign at the front, there will be a negative sign in front of the value of z. So from this, we can have an equation which looks something like this, that mu minus 1.64 standard deviation is equals to 4. So this is our second equation. Now, if we solve these two equations simultaneously, we will get the value for mean and standard deviation. So the value of mean or the value of mu is 10.2, and the value for the standard deviation is 3.77. So that is it for this question. Moving on to the next question. This is from chapter review 7, number 11. The thickness of some plastic shelving produced by a factory is normally distributed. So we can say that the thickness is normally distributed across the mean and standard deviation squared. Right. Let's see if we know the value, we know the mean value and the standard deviation. As part of the production process, the shelving is tested with two gauges used for measuring. The first gauge is 7 millimeters thick, and 98.61% of the shelving passes through this gauge. So the first gauge is 7 millimeters thick, and shelving which are less than 7 millimeters thick can pass through this gauge, and 98.61% of the shelving can pass through this gauge. So we can say that the probability for T to be less than 7 millimeters is 98.61%. Basically, your percentage is your probability. So this is equals to 0.9861. All right. The second gauge is 5.2 millimeters thick and only 1.02. All right. Now let's first work with the first information. Is that we need to find the mean and standard deviation of the thickness of the shelving. So first of all, we need to convert this value of T into Z. So we can say that probability of Z is less than 7 minus mean over the standard deviation is equals to 0.9861. So we know that the probability is 0.9861. Now we just need to find out the value of Z. So when the probability is 0.9861, the value of Z is 2.2. So we can say that this is equals to 2.2. So 7 minus mean over the standard deviation is equals to 2.2. So from this we can create an equation. It's that mu plus 2.2 standard deviation is equals to 7. So this is our first equation. Now let's use the second information. Is that the second gauge is 5.2 millimeters thick and only 1.02% of the shelves pass through this gauge. So shelves which are less than or equal to, probably less than 5.2 millimeters thick can pass through this gauge, and 1.02% of the shelves are less than 5.2 millimeters thick. So we can say that the probability for the thickness to be less than 5.2 millimeters is equals to 1.02%. Your percentage is your probability. So it's basically 0.0102. So first of all, we need to convert this value of T into Z. So we can say that the probability for Z is less than 5.2 minus the mean value divided by the standard deviation is equals to 0.0102. Now, as you can see that the constant value, which is the probability, is less than 0.5, which is a big problem, but we can overcome this by subtracting 1. So this gives us a value of negative 0.9898. Now, since the probability cannot be negative, we can move this negative sign to the left hand side of the equation. So that's negative. Now, when the probability is 0.9898, we the value for Z. So when the probability is 0.9898, the value of Z is 2.32. So we can say that this is equals to 2.32. Right. So 5.2 minus the mean over the standard deviation is equals to 2.32. Now there's a negative sign at the front, so there will be a negative sign at the front of the value of Z. So this can be rewritten as mu minus 2.32 standard deviation is equals to 5.2. Now if we solve these two equations, we will get our value for mu and standard deviation. So the value of mu is 6.12, and the value for standard deviation is around 0. 0.4, 0.40 or 0.4. So that is it for this question. And moving on to the next question, this is from review exercise 2, number 19. So the measure of intelligence IQ of a group of students is assumed to be normally distributed with mean 100 and standard deviation k. So we can say that let's say that the IQ is x. X is normally distributed across the mean and standard deviation squared. Find the probability that a student selected at random has an IQ less than 91. So basically we need to find the probability for x to be less than 91. So first of all, we need to convert this value of x into z. So z is less than 91 minus the mean value divided by the standard deviation. So this will give us a value of negative 0.6. Now z cannot be negative, so we can rewrite this using this formula, which is 1 minus probability of z is less than 0.6. If we're still confused about this formula, you can go back to the previous lessons in this video and clear up your confusion. Right, so when the value of z is 0.6, we need to find out the probability from the statistical table. So when z is 0.6, the probability is 0.7257. So we can replace this with 0.7257. So this is equals to around 0.2743. Now moving on to the next part, the probability that a randomly selected student has an IQ of at least 100 plus k is 0.2090. So at least an IQ of 100 plus k. Alright. So let's assume that the mean value is 100. We do not have to assume it. They have given us the mean value is 100. So if we sketch the normal distribution curve, the mean is 100. So this is the mean. So 100 plus k will lie somewhere around this part. We do not know the value of k. So this is 100 plus k. So a student which has at least an IQ of 100 plus k. So a student which has an IQ of at least 100 plus k. So he can have an IQ of 100 plus k, at least 100 plus k, or maybe greater than 100 plus k. So the region they're talking about is this region. So the probability of this region is 0.2090. So it's 0.2090. Alright. Now we can say that the probability for x to be greater than 100 plus k is 0.2090. First of all, we need to convert this inequality sign into less than. So we can write this as 1 minus probability of x is less than 100 plus k. So it's 0.2090. Now, if we simplify this equation, so this gives us a value of 0.791. Now we need to convert this value of x into z. So we can use the formula, the value minus the mean value divided by the standard deviation. The standard deviation is 15. So that's 15 is equals to 0.791. So this is basically k over 5. I mean k over 15. Now when the probability is 0.791, we need to get the value of x from the statistical table. So when the probability is 0.791, the value of z is 0.81. So we can say that this is equals to 0.81. So k over 15 is equals to 0.81. So k is equals to around 12. So that is the answer for this question. So that is it for today. I hope this session has helped you. If you found it useful, don't forget to like, share, and subscribe for more exam-focused content. See you in the next one. Take care and keep practicing.